Hello, everyone, and welcome to our presentation today. The topic of today is the AI effect, scenarios on jobs and salaries. My name is Paul Arsuf, and I'm the founder of the Decentralized Web project. We're building a decentralized communication and advertising platform. And recently we did release a marketplace for NFTs based on three-dimensional objects. But I'm going to talk about our about our projects in the end of this presentation, and let's come back and start talking about the AI effect. Some people, they say the predominant thinking of people today is the AI would not take your job, but someone using AI might. So this talks about total replacement of jobs by AI, and this is probably going to happen in the future, not near-term future, but in the future. But what about the near-term effect of AI on jobs? And so in this post, I would put argument that AI would not take your job, but it will take your ability to charge a premium for it. So it means that currently AI is probably not going to totally replace your job, but many jobs which were skill jobs and they charge premium salary, and they are getting premium money for it. These type of jobs are no longer going to be able to charge a premium for the work which is done. The question isn't really whether machines will replace humans. The question is one of the biggest distractions of our time. The question that really matters is whether humans will still command a skill premium once they're augmented by machines, and if so, which skills will preserve that premium and which ones will not. The debate on the effect of AI on jobs is repeatedly distracted by the question of replacement through automation, when the factor that really drives our engagement with our careers is the ability to own skills which grants us a skill premium, and charging for this skill premium. And AI is perfectly posed to attack not your job, but your actual ability to charge a skill premium for it. In particular, we would look in this presentation at three key ideas throughout this presentation. The first one is the 4 ways that augmentation rebundles jobs. The second one is the 3 ways that humans attract skill premium. And the third thing we are going to look at is the 3 ways that AI erodes this skill premium. But let's look at the first one, unbundling and rebundling of work. Every job is a bundle of tasks, and some of these tasks require specialization and some don't, but they still remain part of the bundle, as the cost of unbundling and delegating those tasks may be high. Every new wave of technologies, including the ongoing rise of general AI, attacks this bundle. We will be having substitutes and complements. New technology may substitute a specific task. For instance, intelligent scheduling tools may fully substitute a task previously performed by a human. New technology may also complement a specific task. For instance, improvement in AI provide diagnostic support to doctors and radiologists, enhancing their ability to perform the task. First order thinking suggests that technology as a substitute automation is bad, and that technology as a complement augmentation is good. So we have automation versus augmentation. However, to understand whether technology has a net positive or net negative impact on job, it's important to think through the effects of augmentation on the job bundle described above. Depending on the effects on the bundle, the skill premium, the ratio of the wage of skilled workers versus unskilled workers for that job category may increase, decrease, or remain the same. The skill premium and the rebundling of work. So what would it be? There are four possible ways in which the job bundles gets rebundled. Scenario one is like we're going to look if the status quo remains. First, there is no shift in value from the job bundle. AI augmentation helps the worker, but there is no substantial improvement in their ability to capture value either through productivity improvements or through leveling up to include higher value tasks in the job bundle. The outcome of this scenario is there are not going to be any effects on the skill premium. Technology has neither an upward nor a downward pressure on your salary as a skilled worker. And we believe the effects of generative AI will skew less in this direction and more in the other three directions, which we will describe now. The scenario 2 is the value migration. In this scenario, there is a shift in value towards the job bundle. AI augmentation migrates value towards a specific job bundle largely because the worker benefits from productivity improvements, more of the same, or because they level up to include higher value tasks in the job bundle, more of the different. So the outcome of this scenario is your ability to charge a skill premium increases. Like for example, augmented by technology, you can now charge a higher salary for the same skills. The scenario 3 is commodization. And commodization is one of the lesser understood effects of augmentation. It plays out when one or both of two factors come into play. The factor one is augmentation absorbs value from the specialized tasks and commoditizes the tasks over time. And the second factor is augmentation lowers the skill barrier to entry to the specialized tasks, increasing the potential base of workers who can now perform the task. Without a significant shift in value or growth in demand, this increased competition reduces the worker's ability to capture value for the task. The outcome of this scenario is your ability to charge a skill premium would actually decrease. So as others in your job category increasingly use technology, your ability to sustain your salary is going to start decreasing. This scenario is very likely with AI in general and generative AI in particular, owing to its ability to commodify knowledge and commoditize knowledge-oriented tasks. And we are coming to scenario 4, the eventual substitution. Finally, the end game of augmentation could very well be automation and substitution instead of augmentation. This may play out because of data-driven learning effects. As workers increase use of augmenting technology, they generate data needed for model training and fine-tuning, which constantly improves model accuracy and specialization. Eventually, the model becomes specialized enough to fully substitute the task. And the outcome of this final scenario is your job is going to get substituted. So we went over part 1 and we're coming to part 2, and we're going to be looking at 3 sources of skill premium. Let's get back to the central argument of this presentation that AI would not eat your job, but it will eat your ability to charge premium for it. So we would explore 3 sources of skill premium, and the first one is skilling advantages. The skill premium that a higher skilled worker commands over a low skilled worker. The second advantage is learning advantage, the ability to defend and grow the skill premium throughout continuous learning. And the third advantage is managerial advantage, the added skill premium associated with combining skilling and learning advantages with planning and resource allocating capability, which are attributes of managers and management tasks performed by specialized worker. So let's look at these 3 factors that drive erosion in the skill premium. The first one is skill premiums on specialized tasks. Workers who perform specialized tasks and command a skill premium over unskilled workers will lose that skill premium if AI enables low-skilled workers to perform at par with the higher-skilled ones. As we as it is explained in some other presentation, um, when technology augments skilled work and enables historically low-skilled workers to perform at par with historically high-skilled workers, such augmentation may makes workers more substitutable and eventually commoditizes the job. AI augmentation makes high-skilled knowledge workers relatively more substitutable by lowering the skill barrier to achieving the same performance. Augmentation improves productivity and output, but does so to a greater extent for those with lower skills than for those with higher skills. When this plays out, the worker becomes more substitutable as the skill becomes more commoditized. The second effect is the skill premium on learning advantages. As explained above, skill commoditization is the first effect of AI, but that in itself isn't unique to AI. Previous technology cycles also eroded the skill premium on specialized tasks. AI is unique in its impact on learning advantages. Consider the axe welding example. Up until the start of the 20th centuries, axe welding was a high-skilled job. Axe welding in the context of, for example, tree cutting. In order to be any good at logging, you needed to perfect the right angle of the axe swinging as well as the grip on the axe throughout years of practice that developed both muscle and like they develop muscles and they develop a muscle memory. But the invention of chainsaw changed all of that. Low-skill loggers who lacked the knowledge of the muscle memory to perform well could now perform at a much higher level of effectiveness compared with simple axe wielding. The chainsaw was a technology that commoditized axe welding as skill, but axe welding arguably has diminishing returns to learning once you have reached a certain level of skill. There's only so much further improvement achievable through learning beyond that point. A lot of knowledge work is quite different. Knowledge work requires you to constantly keep learning. Take healthcare, for example. The average physician gets through about 5 to 8 years of medical schools and needs to continuously own their craft over the course of a long career. Law is another field where learning advantages command skill premium. The skill premium here is attached not merely to skill specialization, but to ability to grow and defend that premium throughout continuous learning. But AI attacks this skill premium because of its ability to learn at scale. AI commands commoditization by continuous absorption of skills. And not only this, but it does a fast absorption of skills and knowledge as well. The more successful the AI is at augmentation, the more often it is used, the more data it captures to get trained, and the more effective it gets at future augmentation. So we would take healthcare again as an example. AI commoditizes and absorbs primarily knowledge and learning advantages that workers, like in this case doctors, may have developed at a specific specialization as a doctor. As AI augmentation plays out, doctors are constantly training the model, driving more of their skills into the model. In China, for example, a company called Pinkan Good Doctor started out as a telehealth platform with AI augmented doctors treating patients over the platform. Several years of model training later, the AI model now beats human doctors at many tasks. The AI has moved on from augmentation to substitution. With large language models, the scope of knowledge that can be commodified and absorbed into a model increases further, increasing the potential for a similar commoditization to play out across a larger range of jobs. Much large Google Map absorbs Kabi navigation skills and productizes it to enable anyone to navigate effectively. Large language models absorb knowledge, potentially enabling low skills or less informed actors to perform tasks that were previously handled by so-called high-skilled actors. This is the second way AI attacks the skill premium. The third way is skill premium on managerial advantages. Here, a common group of narratives about the impact of AI on work. AI will always need humans in the loop. What do humans excel at? A bunch of things actually. Original thoughts, soulful and not just creative expression, relationships, and managerial goal orientation, to name a few things that human excel at. To actually get things done, you need one or more of the above. And technology is rarely good at substitution this. That is why humans are needed in the loop. Except that managerial goal orientation may not be the sole domain of humans for long. Enter AI agents. To define AI agents, we will borrow the definition proposed by some researchers. software that uses artificial intelligence to pursue uh, agents are goal-seeking, and that is what makes them different. When most technology aims at task substitution, agents go beyond tasks to actually seek goals and perform and complete these goals. Um, every agent operates with at least one goal and possibly more than one. In order to accomplish one or more goals, an agent needs to do these things. First, it scans and observes the current state of the environment. The second thing AI agent does is plan. It sets a plan, deconstructs the goal into constituent tasks, which collectively transform the environment towards achievement of the goal. And the third thing AI agent does is it acts. Uh, it acts on the plan, leveraging other agents and digital resources, constantly monitoring the progress by restraining from step one to adjust the plan in response to the changing environment. AI agents are in stark contrast to traditional deterministic software, whether programs do the scan and plan and then encode instructions into code for performing the act. In summary, AI agents are cool. They get the job done. Goal seeking is not the locus of rebundling tasks. So what we are driving at is this. Goal seeking has thus far been critical reasons for keeping humans in the loop, even when technology substitutes individual tasks. A human is still involved in uh, combining machine-performed tasks with the tasks they themselves perform, the human-performed tasks, towards the performance of a specific goal. AI agents are unique, unlike other technology, in that they can leverage goal-seeking behavior to rebundle tasks and completely replace the human performance in the job. Here is how this plays out. First, an AI agent deconstructs a goal into constituent tasks. It analyzes these tasks to understand their nature, complexity, and interdependencies, and categorizes the sequences then towards contribution to the goal. Once tasks are categorized and aligned with the goals, the agent allocates resources, including calling on other agents towards execution. Agents can continuously adapt and adjust tasks, bundling strategies based on a changing environmental information. They may reevaluate priorities, resequence tasks, or change the other agents they're working with. In a perfectly competitive market of agents, an agent should have sufficient information to map the most appropriate agent to do the tasks. It is agents all the way from top to bottom. Um, Owning to the uh, goal-seeking behavior explained above, AI agents rebundle tasks towards specific goals, impacting how work is organized and executed. The restructuring occurs at both individual and organizational levels, ultimately reshaping job roles and team dynamics. Goal accomplishment is the real product of AI. But how AI agents erode the skill premium. Agents may not eat your job, but they may eat your human in the loop advantage. In previous technology ways, humans often lost the skill premium associated with tasks being augmented, but they would retain the associated capability of environment scanning, planning, and resource allocation across human and technology resources. Agents take away this managerial advantage of the human in the loop who primarily performs environmental scanning, planning, and resource allocation. Uh, Yes, it is early days yet for agents, but as models develop and as more agents get created, a perfectly competitive market of agents could start replacing multiple levels of managerial advantages. Low level, low end managerial work gets replaced initially, but over time, complex managerial work may also struggle to command a premium. Of course, in rapidly evolving environment, resource allocation requires original thought, and some just few humans may effectively outsmart AI there. But the vast majority of the skill premium of human in the loop gets progressively eroded as these three effects laid out above would play out. Um, there is going to be centralized market mining, which accelerates erosion. Finally, as workers get more commoditized through AI, the work lends itself to a greater deal of centralized market making. Centralized market mining further accelerates the erosion of the skill premium. To understand how this works out, let's look at market where this has played out at scale. In the market of local transportation, the advent of Uber changed the mechanics of job discovery, or in this case, the mechanics of finding your next ride. Cabbies could either be assigned job by the algorithm and compete with other five-star rated map augmented amateur drivers, or they could stay out of the system and miss out on the demand coming in through Uber. Cabbies lost their negotiation power, leading to a variety of effects. They had to accept rides without knowing the destination. They had to adhere to acceptance and cancellation rate metrics. They had lost not only the ability to set the price, but also the agency to accept or reject work opportunities based on whether it made commercial sense. Centralized market making erodes the skill premium by putting increasingly substitutable workers against each other and driving the clearing price of job allocation to a bare minimum. Essentially, centralized markets combined with the three factors above that erode skill premium convert the job market into a commoditizes market seeking the lowest possible market clearing price. The more technology commoditizes your skills, the faster your skill premium is eroded through centralized market making. This leads to a cycle of continuous commoditization. Skill absorption into AI constantly drives a greater commoditization. An ever-improving AI model trained by a larger base of users drives continuously commoditization of the skill. Success augmentation expand the training data set not just through driving greater usage among workers, but by fundamentally expanding the overall base of workers training the model. A feedback loop is set in motion here where greater productization and democratization of the knowledge starts accelerating the commoditization. A combination of these effects have eventually erodes the skill premium associated with the job. The commoditization, the commoditized human in the loop. Thus, AI is your job. It doesn't really matter. That's really the wrong question to be observing over. What is far more important is to determine whether AI gets to eat your skill premium. Yes, there are human advantages like original thought, soulful expression, which, when combined with an effective use of AI, can help command a higher skill premium. But the vast majority of jobs where human in the loop largely relies on skill specialization, on learning advantages, on managerial capabilities. AI will chip away at the skill premium of those jobs which those jobs command. Eventually, the factor that really drives our engagement with our careers is the ability to own skills which grants us skill premium. The effects of AI on basic wage loss through AI-driven job displacement can be counted through policy by setting up an AI tax on specific activities. But the effect of AI in the skill premium are far more difficult to address. And yet we remain obsessed with the human in the loop argument. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing this. And I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov, and I'm the founder of the Decentralized Web project. We are building a decentralized communication and advertising platform, and we are achieving decentralization beyond using of blockchain technology. This is non-blockchain type decentralization. And recently we did release marketplace, and we did release a collection of NFTs based on three-dimensional objects. What is interesting, what is special and unique about our 3D object is we did build our own 3D software engine, and usually users of 3D objects, they casually use game engines to load and display this 3D object, and the most popular game engine which 3D object creators are casually using are two game engines. One of them is called Unity and the other one is called Unreal. But from the very beginning of our project, we decided to build our own 3D software engine, and this 3D software engine, what it does is it reads the file of the 3D object, it opens a window on a computer display, it loads the file of the 3D object, and it starts animating this 3D object of the 3D NFT in a way of constantly moving it in a random fashion around the window. But in addition to this basic ability to read the 3D object file, load this 3 file, open the window and start animating the 3D NFT, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of 3 different voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are 3 different flavors of voices. A voice can be spoken either in a normal speed, or it can be spoken in a fast speed, or it can be spoken in a slow speed manner. And for example, if we take a male voice and it is spoken in a slow speed manner, this voice can come as the voice of a very masculine person or the voice of an old person. If on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. The second additional and important capability of our 3D software engine is the capability of voice recognition. If we, for example, have a 3D NFT which is constantly moving around a window, being animated, we can then issue our very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue the following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. With the next additionally important capability of our 3D NFTs is the capability of them having basic artificial intelligence. Wow, really? Wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to tell you who they are. You can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3, or about decentralization, or about the country called Russia. The last additional and important capability of our 3D NFTs is the capability of us seeing them in real 3 dimensions. Currently, 3-dimensional objects, including our 3D NFTs, are commonly displayed on flat 2-dimensional computer screen. But we are going to be having a version of our 3D NFT which is going to be displayed in a way of stereoscopics. What stereoscopics means is that a part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our 3D NFT marketplace, and probably this is the time of me to tell you the URL and the name of our 3D NFT marketplace. The name and the URL is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is altogether 3D NFT. Then there is dot, then there are 2 words, decentralized and web, and they are all together, decentralized web. Then there is dot, and it ends with org. Once again, 3D NFT dot decentralizedweb.org. On the top of our 3D NFT marketplace, you're going to see several links, and when you click on the accessories, then you're going to see a page where you're going to see that we're offering special glasses. You're going to click and order 1 pair of these glasses, and when you receive these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue. Then you can put these glasses on. You can request the displaying of our 3D NFTs in a way of stereoscopics, and then you're going to see the 3D NFT as coming out of the flat 2-dimensional computer screen, and you're going to see the 3D NFT in real 3 dimensions. With this said, I am ending talking about our 3D NFTs collection and our 3D NFT software engine and its capabilities. But I like to tell you a little bit about our 3D NFT marketplace as well. In our 3D NFT marketplace, we have our own blockchain instance, and by having our own blockchain instance, we do not require our users to pay gas fees for deployments of the smart contracts for the non-fungible tokens, and they do not pay a fee for transfers of ownership from one user to another user. Uh, our blockchain runs the same software which runs Ethereum virtual machines, and this is the same software which Ethereum mainnet runs, and blockchains like Binance Smart Chain runs, and chains like Polygon Matic, and chains like Avalanche Avax, and many other blockchains runs. By having our own blockchain instance, then we are not requiring our users to um, do the buying and selling of our 3D NFTs just in one crypto coins, but we allow our users to buy and sell our 3D NFTs in 4 different crypto coins. The current choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. With with this set, I'm I did describe the way of buying and selling of our 3D NFTs in crypto coins, but we are offering a second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. Let's say you are a user of the 3D NFT, you come to our 3D NFT marketplace, you decide to buy the 3D NFT with fiat currency, and then you click on like you're going to be presented with a screen drop down box which asks you either whether to pay with 1 or 4 different crypto coins, or the fifth choice of paying with fiat currency. So let's say you select paying with fiat currency and click the button to advance next. You're going to be asked to put the number of your debit or credit card, expiration date, CVC, and when you click the button to make this payment, what is going to happen is there's going to be a transfer and transaction from your national fiat currency to US dollars, and this is going to be deposited in our bank account. So we are going to follow this action with a second action of the transfer of the initial ownership from our 3D NFT marketplace to you, and you become a current owner of this 3D NFT. So let's say you play with the 3D NFT for a while, and then you decide to put your current 3D NFT for sale. You decide on the price, you put this price, and you declare this 3D NFT as for sale. So let's say a second user comes to our 3D NFT marketplace. They decide to buy the 3D NFT, buy a 3D NFT, and they find and they want to buy your 3D NFT. What is going to happen is the second user, let's say they go through the same choices of paying with crypto or paying with fiat. They select paying with fiat currency and click to advance next. They put their debit or credit card and they make the payment. So what is going to happen is there is going to be a conversion from the national fiat currency of the second user, which could be different than your national fiat currency, as there is going to be a conversion from the second national fiat currency to US dollars, and it's going to be deposited in our bank account. we're going to follow this section with um, transfer of ownership from you, the first user, to the second user, and the second user now becomes current owner of this 3D NFT. Uh, so we're going to follow this action with the third action with transfer and of conversion from US dollars from our bank account to the national fiat currency of you, the first user, and this conversion is going to be from US dollars to your national fiat currency, and you're going to get a deposit of the proceeds from the payment of the sale of the 3D NFT and you're going to receive it in your bank account. With this said, I'm ending this little introduction of our 3D NFT marketplace, and I like to tell you a little bit about second project that we are working on. This second project is about electric vehicle charging and the upcoming exponential growth of the number of electric vehicles coming and replacing internal combustion engines used by people for transportation. With this exponential growth of electric vehicles, there's going to be increased problem of how these vehicles are going to be charged, and we are proposing the current model of handling of charging of exponential growth is through uh, like uh, uh, some sort of replacement of gas stations with stations where there uh, there are columns which are connecting cars to electric power, and in the same way a car can come charge from this equivalent of gas station and then leave. But we believe that with the exponential growth of electric vehicles, there is going to be a need for a new way of charging these electric vehicles, and we are proposing the model of charging electric vehicles on the parking lot location, whether it be the location of your home apartment building parking lot, or the parking lot of your work building, the building where you work, or the building of shopping malls, or even the street parking spots. And with this, we propose we are working on development of creating of like a switch which is going to do the remote turning on and off of electric power and handle the charging of electric vehicles at the location of the parking lot. And with this said, I'm ending this presentation. Thank you for coming. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.